Now we're going to look at our quantitative variables and some of the graphs and displays we could do for those. And for this, we're just looking at graphs and frequency distributions. Next week, when we talk about Chapter 3, we'll look at some other types of values that we can get for quantitative variables. We're going to start out with frequency distributions or frequency tables. Our three quantitative variables in this set are age, children, and education. And I'm going to leave this so it does the frequency and the relative frequency. Now this is another one where we have lots of different values for the ages since the people were just giving their age. So it asks if we want to turn on binning. I'm going to do it first where we don't turn on the binning so you can see what happens. If you don't ask it to turn on binning, then it's going to give you one for each different age that was listed in the data set. This is a lot of different numbers, and this is really not telling us anything at all. Really what we would want to do is go back, do this again, and when it asks us if we want to turn on binning, we're going to say OK this time. What that does is it has StatCrunch create some categories for us. If we were doing this frequency distribution by hand, we'd have to create our own categories. But StatCrunch did it for us. The bad thing about doing this in StatCrunch is we don't have any control over how it does these categories. There's no way to change it. The other problem with doing this in StatCrunch is that technically for a frequency distribution for a quantitative variable, the classes or the categories can't overlap. And if you look at how it lists these classes, it looks like they're overlapping. For example, this one goes from 10 to 20, this one goes from 20 to 30. Now actually they're not, because in StatCrunch what this is actually doing is it's starting at 10 and going up to the last number before 20. So this is actually going from 10 to 19, this is going from 20 to 29, and 30 to 39, and so on. But you wouldn't know that by looking at this. So this is kind of confusing. You have to really make sure that you understand that if you're going to use StatCrunch to do frequency tables. This does give us a good idea of what's happening with our data though. So for the ages, we can see that we had more people in the 50 to 59 age group than anything else. You can look at the actual frequency or the relative frequency. The one with the least number was the 10 to 19 age group. And we can also see that a lot of our data is here between 30 and 70. There weren't as many on either end, but there were a lot in the middle of that. The next one is the children variable. And this one just had a few discrete values because this was something that answered the question, how many? How many children do you have? There were only 8 different answers that people gave for this. We had 2 that happened more frequently than the others. The 0 children had 50 responses and the 2 children had 56 responses. And then as we got towards the higher end of this, we had fewer and fewer responses. For our education variable, notice it skips all the values from 1 through 5. It goes from 0 up to 6. That means that for 1 through 5, there were 0 people that answered the question that way. Next, let's look at histograms. The difference between a bar plot and a histogram. A bar plot is something that's used for categorical variables. A histogram is something that's used for quantitative variables. And there are some differences between bar plots and histograms that make it more important to use them for the right type of data. So let's do histograms for our 3 quantitative variables. Now we can compare the histogram to what we got in our frequency table. If we look at our histogram, we can see that the classes here are actually different than what they gave us in the frequency table. These ones, the classes have width 5 because, say, this one starts at 20 and goes up to actually 24. The next one starts at 25. The next one starts at 30. So these are all width 5, where these classes were width 10. So this is giving us a slightly different result and a different picture of the data than our frequency table over here did. If we want our histogram to match the classes that are in our frequency table, we could go back to this and edit it So we want our bin width to be 10. And now we have a histogram that matches what we have in our frequency table. From this we can see the highest frequency class is the one from 50 to 59. The lowest is the one from 10 to 19. And we've got most of our data grouped in this area, especially between age 30 and age 59. Now the reason that I'm picky about the difference between histograms and bar plots, let's look at a bar plot for the age variable, and we're going to tell it to yes, go ahead and do the binning. Notice the difference between these two. The histogram, there are no gaps between the bars, so we can see this is a continuum of the ages. In this one, it really separates these bars so that we've got big gaps between each of these bars. The other problem with this is if you have a lot of classes, since it puts the classes down here, sometimes this gets really hard to read. We again have this issue like we did in the frequency table where it looks like the classes overlap, because this one goes 10 to 20 and this one goes 20 to 30. So really for a quantitative variable, you should be doing a histogram instead of a bar plot. Now let's look at the histogram for the children variable. This looks like a bar plot. We have all these gaps between the bars. This is just a weird thing that StatCrunch did with this one. If we look at the classes for these, it actually made the class widths 0.5. That doesn't make any sense because that would be saying that we had a half of a child. So what we would want to do with this one to make it look right is go back and tell it that we want our class width to be 1. That fixed the problem. So now we still have one bar for each response in the children variable, but the bars don't have any gaps between them. And this one corresponds exactly to what we had in our frequency table. So we can see we had a couple of high frequency classes over here. And this goes down as we go from left to right. We have more of the data on the left side and a longer tail on the right side. As far as the distribution shape, this would tell us that it's skewed to the right. The direction of the skew is the direction that the longer tail is. So since this has a longer tail on the right, more data on the left, that makes it skewed to the right. The other one we can look at is the education histogram. We have a class width of 1. So this actually shows us all the different responses to the years of education. Now the nice thing about doing a histogram for this one is that it actually shows us where these classes were that had 0 responses. So it actually shows us that there's a gap between the 0 and the 6. That's something that it was a little bit hard to see in the frequency table, and if we did a bar graph for this, the bar graph would not show us that gap. We'd have to notice that for ourselves. Now for this one, if we wanted to group these differently, we could go back and change the class width. For example, if we wanted to make the width 4, that would make fewer classes that we'd have to look at. This gives us a little bit different picture of our data. This tells us that most of our data was in the 12 to 15 years of education. So that would be people that finished high school and possibly had 1, 2, or 3 years of college. Then the next highest one is from 16 up to 19. This is people who had from 4 up to 7 years of college after high school. We can see that these other 3 classes had very few respondents. This histogram does something that our frequency table over here didn't do, so this one we didn't have any way to group those together. Sometimes you have quantitative data that you want to split up by different categories for another variable. So sometimes you have a quantitative variable and a categorical variable that you want to look at the same time. Let's say that we're trying to look at the ages of these respondents, how that connected to how they answered the happy question. One way we could do this is to do a histogram. So we'd want to select age as our column, and then we could group our histogram by the happy variable. It's going to give us 3 different histograms because the happy variable had 3 different possible responses. This is going to divide our respondents up into how they answered that question, and then it's going to do a histogram for the age for each different one of those. Here are our respondents that answered that they weren't very happy. So there were a lot more of these in the younger age group. This went down as our respondents got older. The older the age of the respondent, the less and less of them there were that answered that they weren't very happy. For the pretty happy response, this one has a lot different shape. There are a lot more of them in the kind of middle ages, less on the two ends. And for the very happy response, again, this one has a few more on the younger ages and less in the older ages. Now, if you're doing this in StatCrunch, if you want to have these three graphs side by side, then really you just have to do the three separate. So you have to do this 3 times in a row. Here's our not very happy, here's our pretty happy, and here's our very happy. And we can see the differences in what those look like. Now let's look at another type of graph we can do only for quantitative data, and that's a stem and leaf plot. What this does is it takes the values in the data and splits them up. It makes one of the digits a stem, and then the digit to the right of that is the leaf unit. So in this, it's saying the leaf unit is 1. The 9s right here are the 9 and 19. This would be a leaf of 9 and a stem of 1. So that means they have a 1 in the 10s place and 9s in the 1 place. The nice thing about a stem and leaf plot is that it actually gives us what all the data is. This tells us that there were 3 people in this data set of age 19. We could look at the oldest person in this data set would be this last one here, and they would be 84. We can also use this to look at the distribution shape. The highest frequency would be the 50 to 59 class because it goes over the furthest to the right. We can look at whether the distribution is skewed or whether it's symmetric and bell-shaped. Another type of graph for quantitative data is a dot plot. Now, this one doesn't work for all quantitative data because this uses each individual value in the graph. This one works well for something like the children variable where you only have a few different responses. For children, we only had 8 different responses. We had some discrete values. So the dot plot for this is going to come out pretty well. It's doing 1 dot here for every respondent that answered that they had 2 children. This looks a little bit like a bar graph because we have just these different bars for each of our different values. Now if we tried to do a dot plot for the age variable, this is one that isn't going to work very well because we have so many different answers for the age. This graph really doesn't tell us very much. The only thing that we can really see from this graph is that at the 70 plus ages, there aren't as many respondents as there were in the younger ages. So overall, for our quantitative data, here are the types of graphs and displays that we can do. Frequency distributions or frequency tables, histograms, stem and leaf plots, dot plots. Here are different ones for categorical data. Here are different graphs for quantitative data. The only one really that's the same is that we can do frequency distributions for either one of these two. This is why it matters whether the data is categorical or quantitative, because we are doing very different types of graphs for the two things.